Hello all. In this video, we will see concurrent structures fork and join with the help of an example. So here is the question. Consider the following pseudocodes. We are given these 7 statements. We want to construct a precedence graph illustrating statement level concurrency. And then using that precedence graph, we wish to write a concurrent program using fork and join. Okay, so let us draw the precedence graph first. So as you can see over here that we have statement 1. Now if we see that statement 2 is reading value of p, which is modified by statement 1. This means that statement 2 is dependent on statement 1. Means statement 2 cannot run before you execute statement 1. So first statement 1 must run, then statement 2 will run. Likewise, if you look at statement 3, it reads the value of q, which is again modified by statement 1, right? So statement 3 also is also dependent on statement 1, right? Statement 3 cannot run before you execute statement 1. Okay. Then when you look at statement 4 reads the value of x, which is modified by statement 2, right? So here we have statement 4, which is dependent on statement 2. So statement 4 will run only after you execute statement 2. Likewise, statement 5 also reads the value of x, which is modified by statement 2, right? So statement 5 is also dependent on statement 2, right? Statement 5 will run only after you execute statement 2. Then when you look at statement 6 reads the value of a and b, which are modified by statement 4 and statement 5. Right? So statement 6 is dependent on two statements, statement 4 and statement 5. And finally, when you look at statement 7 reads the value of c, which is modified by statement 6. So naturally statement 7 is dependent on statement 6, and statement 7 is also reading the value of y, which is modified by statement 3, right? So statement 7 is also dependent on statement 3, right? So statement 7 cannot run before you execute statement 6 and statement 3. Okay. Now after constructing this precedence graph, we will write the program. Concurrent program. Write a concurrent program. It's very easy. Assume we have one thread which is currently executing this concurrent program, single thread. That single thread will execute statement 1. Okay. Now you see that statement 2 and statement 3 can run in parallel, right? So our existing thread can execute statement 2, and a newly created thread, this newly created thread, we can create a new thread using fork. So fork, and then we will assign some label. Right? So what will happen because of that is existing thread will create a new thread, and that new thread will begin its execution from label 1, means from this place, and our existing thread will continue executing the same code, right? So after creating a new thread, existing thread will execute statement 2, and a newly created thread, because of fork, which will begin its execution from label L1, will execute statement 3. Okay. Then after you execute statement 2, you realize that statement 4 and statement 5 can also run in parallel. Okay. So what can be done is we can create another thread which will begin its execution from say label L2, So here is maybe label L2. So a new thread is now created. This new thread will start its execution from label 2. Our existing thread can now safely execute statement 4, and a newly created thread can execute statement 5. Now the thing is that here what we see is now we have to make sure that the thread which executed statement 4 and the thread which executed statement 5 should join together, right? So what we have to do is we have to use a join statement over here. Okay, and for this purpose we will use a variable, a count variable c1, and since there are two branches which are getting merged, there are two threads which are getting merged into single thread, the count is initialized to 2. So what we do now is we execute this join and we write the variable name join c1. What will happen that existing thread will execute join c1. The newly created thread can also come to the same statement join c1. So both threads will execute join c1. Now the interesting property of join is one of the thread will survive, the remaining threads would be destroyed. So there are two threads executing join c1. One of the thread will survive, the other thread would be destroyed, okay, because of the property of join. And then we have only one thread remaining, which is either the current thread or the thread which executed statement 5. It all depends upon what order they execute the join statement, but only one thread will continue further, which will execute statement 6. Okay, and then we again have a join happening because statement 7 will run only after you execute statement 6 and statement 3. So the thread which executed statement 6 and the thread which executed statement 3 will join together. So we have another join statement for another counter variable c2. Now we assume that these variables are global, which are accessible to all the threads, and that is also initialized to 2 because there are two branches getting merged. S6 and S3 are getting merged into S7. Our existing thread will anyway execute join c2. Our newly created thread which executed statement 3 would also execute the same join statement. So go to L4 will make sure that it comes over here. Again, because of the property of join, two threads will execute join c2. One is the existing thread which executed statement 6, and the other thread which executed statement 3 will also come over here to execute join c2. Two threads execute join c2. One of the thread would survive, the other thread would be destroyed, and whichever thread survives will execute statement 7, right? So this is how you write the concurrent program using fork and join. I hope you have understood this. Thank you.